Hello, so today we will be going over problems 11 through 15 in the 2008 AMC 12A. We have already covered problems 1 through 10 in a different video. Okay, problem 11. 3 cubes are each formed from the pattern shown. They are then stacked on a table, one on top of one on top of another, so that the 13 visible numbers have the greatest possible sum. What is that sum? Okay, so first we'll draw 3 cubes. Three cubes on top of one another, right? Okay, that does not look like a cube, but it gets the idea, right? Okay, great. So those are the cubes. 13 visible numbers. Okay. In this first cube, how many visible numbers do I have? I can see the top 1, 2, 3, 4, 5. Okay, I can see 5 in here. I cannot see the bottom one. I can't see this one right here. Okay, so 5. Here I can see 4 because I can't see the top and bottom, but everything else is visible. And same thing here, 4, right? 5 plus 4 plus 4 is 13, so that means this is good, or it should be good, because the numbers are adding up. And yeah, okay, so 5, 4, 4. Okay, I'll write that up here. 5, 4, and then 4. Okay, so we want the least numbers in the faces that are not visible to us, because we want the greatest possible sum to be visible to us in the 13 visible numbers, right? So that means that I would want a 1 over here, because 1 is the least number out of all these numbers here. So and then here, okay, so okay, remember that this face exists for the top and the bottom cube. They're two distinct faces. You can't like join them together and say that 1 is also true for the middle cube right here. No, it's different. Okay, so for the middle cube, we cannot do 1 and 2 because they can't be next to each other, because like you can't have 1 right here and 2 right here. That's not gonna work. But you could do 1 and 32, you could do 2 and 16, you could do 4 and 8. You can do like, I think you can do that, right? I think 4 and 8 would be the least sum, which is 12, because if you do 1 and 32, that's 33. 2 and 16 is 18. So 12 is the least. So you would do a 4 right here and an 8 right here. Same thing for the bottom one. You would do a 4 right here and an 8 right here. Okay, now let's do the sum. So for the top cube, the sum would just be everything except for 1. So 2 plus 4 is, okay, let's do it like this. Okay. Okay, so everything except for 1, okay? So 2 plus 4 is 6, plus 8 is 14, plus 16 is 30, plus 32 is 62. For this one right here, for the middle cube, you would do everything except for the 4 and 8. So 3, 35, 51. And same thing for the bottom one. You would have 51. 62 plus 102 is 164. And that is our final answer, which is C. Okay. Okay, moving on to problem number 12. A function f has domain 0, 2, and range 0, 1. The notation denotes this. Okay, what are the domain and range of this? Okay, so x plus 1 has to be between 0 and 2, right? Yeah, x plus 1. I think x plus 1 should be between 0 and 2. So we can say that 0 is less than equal to x plus 1 and 2. Okay, so that means that -1 is, yeah, x is greater than equal to -1, which is less than equal to 1. So x is going to be, -1, 1, right? So that's our domain. So okay, great. So we can eliminate C, D, and E because they don't have that. A and B have it, so we need to find the range now. So for the range, we can do, okay, so 0 is less than equal to f, which is less than equal to 1. Okay. Okay, and then 1. Okay, so first we got to do negative, right? Yeah, okay, negative f is less than equal to... So between 0 and negative 1, right? Negative 1 and 0. Because I just multiply by a negative 1? Yeah. Okay. And then I can just add 1 to both sides. I mean, to all the sides. Because I'm trying to do 1 minus f. And I get 0. 1 minus f, 1. So f is 1 minus f is greater than equal to 0, but it's less than equal to 1. So my range is going to be 0, 1. And that matches up with B. So my final answer would be B for this problem. Okay, moving on to problem number 13. Okay, point A and B lie on a circle centered at O, and angle AOB is equal to 60 degrees. A second circle is internally tangent to the first and tangent to both OA and OB. What is the ratio of the area of the smaller circle to that of the larger circle? Okay, let's visualize this first. So we have a circle. Okay, that does not look like a circle. Oops. Okay. I'll use this for the circle. Okay, that looks a little bit better. I hope that looks... Yeah, I think that looks a little bit better. Okay. And then I have... OA. Okay, so I have a A on the circle and a B on a circle, right? AOB. Okay, so this is going to be O. And it's going to be something like that, right? Okay, so AOB. This is 60 degrees. Okay. Second circle is internally tangent to the first. So the circle's tangent to this, this, and this. Okay. So I'll use blue to draw this circle, which is something... Okay, that is not... Oops. Okay, I gotta draw it again. Okay, that's better. Okay, I think I messed up my... Okay. Okay, I'll just redo the whole thing. Okay, circle right here. Something like... Okay, that is not good. Okay, that looks better. And then I have a circle just like that. Okay, that does not look like the best. Here, I can just edit that. Okay, great. Okay, that looks a little bit better. Okay, I'm working with a mouse here, so yeah, it's not gonna be the best, but I think it's pretty decent. Okay, I have A, B, and O, and we know that this is going to be 60 degrees, right? Okay, so that is what we know about this. If that's 60, okay, so let's... Okay, ratio of the areas. Okay, we're trying to find the areas. Okay, so this is the center of this. Okay, we can do something like that. So each of these is R, right? We can treat each of these as R. Okay, if each of these is R, that means... Okay. Or we can do this. We can do it... we can do something like that. That's also R. And this whole thing... This is a triangle now, right? We can do this as 90 degrees. This is going to be 30 because this is bisecting, right? This is 30. 30, 60, 90. So that means that if this is R... Right, that means that this whole thing is going to be 2r, because for 30 degrees it's going to be x x root 3 and then 2x, right? That's for 30, 60, 90. For 45, 45, 90, it's going to be x, x, and x root 2. So that's different. Okay. So we know that this whole thing is 2r, and this is r. So that means that this to this is also r, and this is r. So everything is r. So that's great. So what we can do is we can figure out the ratios of the lengths of the circles, and from that we can get the area, right? Theta over 360 times 2 pi r, theta over 360 times pi r squared. Okay? Okay, so, okay, if this entire thing, this is r, this is 2r, this to here is 2r, that means this is all 3r. So the radius of the bigger circle is 3r. So r to 3r, or 1 to 3 is the ratio of their radiuses. And from the ratio of the radiuses, we can figure out the ratio of the areas, because pi r squared, if we square both sides, we get 1 to 9. So 1 over 9 is our answer, which should be, oh, it's B. Okay. So our final answer is B. Okay. Okay, moving on to problem 14. Okay. What is the area of the region defined by this inequality? Okay. Okay, this is pretty difficult to find it like this, but what I can do is I can shift this entire graph, right? Because shifting a graph won't like affect the area. It's just going to affect like where the graph is on like the coordinate plane. It's not going to affect like the actual area. So I can just shift this. So I can do 3 times the absolute value of x minus 6 plus 2 times the absolute value of y plus 7 over 2, right? That's going to be less than equal to 3. And what I can do is shift this left 6. Yeah, left 6 and up 7 over 2. If I do this, right? Shift it left 6 and okay, yeah, I think I did it right. Okay. So then what it would be is 3x plus 2y, right? This would just go away. Yeah. Is equal to, oops, sorry. This should be less than equal to 3. Okay. Okay, this, okay, the original equation was something like this, right? 3x minus 18 plus 2y plus 7 is less than equal to 3. Okay. Okay. Okay, so after these shifts, what we can do is, okay, we need to plot this now. Okay, let's think about that. So now that it's centered, okay, now that it's centered, what we can do is we can plot the different, we can plot this. So we can start with the generic one with both of them being positive, and that would just be 2y less than equal to 3 minus 3x. Divide both sides by 2. Okay, I'm just gonna negate this. I'm just gonna negate this inequality, and I'll just make it equals to, just to make it a little simpler. Okay, so this is, I'm gonna get rid of all of this. So basically all I did was shifted this, right? I shifted this so that I get this, and that doesn't like affect the area. So I can plot this. This is positive 1.5 and then negative, so something like that, right? Then I can make both of them negative. Let's make the both of them negative. Divide by -2, and I get the same slope but a different y coordinate. Okay, that is not negative 1.5. Should be a little bit. Oops. Okay, that's a little bit better. So we're just gonna assume that this is negative 1.5, right? Okay. Now let's make only x negative and y positive. And if I do y, okay, why am I... Okay, I'll just write the inequality. Yeah, before, I know I said that I wouldn't, but like now I'm just writing the inequality sign. Okay, so y is less than equal to, okay, 3 plus 3x over 2. So positive y, positive slope. That would be something like that. So I'm going to assume that the other one's going to be something like that, right? If I do 3x minus 2y is less than equal to 3. So negative 2y is less than equal to 3 minus 3x divided by negative 2 divided by negative 2, negative and positive. Okay. Okay, great. So I get sort of like a rhombus, I think, right here. The area of that is just 1/2 d1 d2 and 1/2 times, so we know that this is 1.5, so this is also 1.5, so this whole thing is going to be 3. We know that, okay, so we can write that down first, and then we know that the distance from here to here, okay, let's think about that. Okay, so we found that this is 1 point. Okay, so this is 1, right? Isn't this 1? Okay, yeah, that's 1. Yeah, I'm pretty sure that's 1, right? Because this is where y is equal to 0. Y is equal to 0 here, then x is going to be less than equal to 1. Or it could be negative. Yeah, okay. So this should be a 1 and 1, which is 2. And so the area would just be 3, right? So final answer A. Okay. Oops. Okay, moving on to... Okay, I'll zoom in a little bit. So, problem 15. Okay, that's a little too much. Maybe like that. Okay, that's better. Okay, moving on to problem 15, which is the last problem for today. Okay. Let k equal 2008 to the second power plus 2 to the 2008. What is a unit? 2 to the 2008th power? What is the unit digit of k squared plus 2 to the k? Okay, this is pretty simple. So we have to think about 2 to the 2008 first. So we know that 2 to the first is 2. 2 squared is 4. 2 cubed is 8. 2 to the 4th is 16. 2 to the 5th is 32. And 2 to the 6th is 64. So we notice a pattern. 2, 4, 8, 6, 2, 4, 6, 8, sorry, 2, 4, 8, 6, 2, 4, 8, 6, and so on. So it repeats every 4 times, right? We can do 2008 divided by 4, which is 50. Oh, that should be, okay, I'll just do it right here. 50, 200, 0, 502. Oops, it should be 502. So we get that 502 is this. That means that it divides evenly. So that means that the final, okay, this is, sorry, this should be 6, not 16, because we're talking about unit digits here, right? So it divides evenly. That means that the unit digit of 2 to the 2008 is 6, okay? Which is the same as, we can write this as 2 to the 4th. We can simplify 2 to the 2008 as 2 to the 4th. Okay, so we can do 2 to the 2008 2 to the 2008 is equal to 2004, right? We can say that, or not equal to, we can just say that, right? We can simplify it. Okay, and then we get that 2008 to 2008 squared. Let's think about that. So 8 squared is 64. 18 squared is, I believe, 324. 28 squared. Okay, so we got to do 28 squared. 4, 6. 16 plus 6 is 22. 0, 6, 1, 5. That should be 4, 8, 7, right? Or did I do something? Wait, let's do that again. I think I messed up. Okay, so I got 4, 6. 16 plus 6 is 22. 0, 6, and I got a 1, and I get a 5. Okay, so 4, 8, and 7. Okay, 784. Okay. So we get that 784. So that means our unit digit is 4, right? Okay, so our unit digit is 4. And if you think about it like this way, like uh whenever we have 8 like ending, and then we always have 4 as a unit digit. So I can say that this is the same as like 8 squared basically. Okay? So 8 squared plus 2 to the 4th. I can simplify all of this, which is amazing because it makes it so much easier. 2 to the 4th plus 8 squared is equal to k. This is so much easier now. This is just 16 plus 64, which is just 80. So we can just say k is equal to 80. Unit digit of 80 squared plus 2 to the 80. Okay, we can apply the same trick as before. 80 divided by 4 because the pattern repeats every 4 times. 80 divided by 4 is just 20. That means that evenly divides. So this unit digit is going to be 6. And here, okay, so we know that this is 6400. So this has a unit digit of 0. And we don't really, like, we don't need to worry about this because this ends with 0. So that means our answer is going to be 6, which is D. Okay, so I hope that helps. If there are any errors or any mistakes that I made, please let me know. Thank you so much for watching.